business that runs like a well-oiled machine. That's everyone's goal. Easy to achieve? Sure, if you keep your hydraulic systems properly maintained. Then you won't have any problems delivering the goods on time and on budget. Unfortunately, that was something I learned the hard way. The day the line stopped. It happened so fast, we weren't prepared for it, although we should have been. The machine shuddered to a stop at 10 a.m. We needed to get the complete order out by the end of the day. We could have switched the molds to another machine, but all our other machines were running tight schedules. And to make matters worse, we had a contract to deliver the goods on time or face a sizable fine. The production manager was furious. The operator was stuck with downtime. The scheduler was on the phone doing damage control. Tom, the maintenance manager, started tearing the machine apart. Everybody had an opinion, but it didn't take Tom long to find the problem. It had happened before. The servo valve had seized again. My job was to make sense of this problem. I needed to understand how it happened, and I knew Tom would have the answers for me, including some I didn't want to hear. What went wrong, I wanted to know. How did the servo valve get so fouled up? His one-word answer said it all. Contamination. Where, I asked. Where it always is, he responded. In the oil. It's the contamination in oil that contributes to 90% of hydraulic system failures. Contaminated with what, I asked. Clearance-sized particles, he said. And what are clearance-sized particles? They're tiny 1 to 5 micron particles of debris suspended in the oil as it circulates throughout the system. Invisible to the human eye, these particles are too small for the inline pressure filtration to capture. They're so small, they pass through the dynamic clearance between moving metal parts inside the servo valve and other components. In fact, their size almost matches the clearance. That's why they're called clearance-sized particles. These contaminants are propelled through the componentry in very high volume. With the thrust of a rocket, they wreak havoc, literally sandblasting metal surfaces. As the particles are battered about, they break into even smaller particles. The longer they're present in the oil, the more wear-hardened they become. Eventually, they grow harder than the host surfaces, causing exponential damage that results in system failure. And that, Tom told me, was exactly what happened this morning. How did the clearance-sized particles get there in the first place? To understand that, Tom said, we have to look at how the whole hydraulic system works. Typical hydraulic systems consist of 4 major components: an oil reservoir tank, pumps, valves, and cylinders. When it's first delivered, the reservoir tank often harbors manufacturing fines, like metal shavings, welding flux, sand, or dirt. And the new oil that's used to fill the tank is definitely not contaminant-free. An average gallon of new oil actually contains over 12 million solid particles. And if the reservoir tank holds, let's say, 400 gallons, that's a pile of contaminants before we even get started. The pump sucks the oil from the tank and distributes it, along with the contaminants, through to the rest of the system. Before the oil continues to the servo valve and the cylinder, it passes through a pressure line filter. This filter uses a thin pleated media to stop larger particles from contaminating the downstream components. To complete the system, the oil may pass through a return line filter, similar to the pressure line filter, before it flows back to the reservoir and repeats the cycle. So you can see that contaminants are always going to flow through the hydraulic system unless we do something to stop them. But isn't that why we have the pressure line and return line filters, I asked? Aren't they enough? The simple answer is years ago they may have been, Tom replied. Today, they're not. Our pumps, valves, and cylinders have exceptionally tight tolerances. And that means clearance-sized particles can do a lot of damage to them. Pressure line and return line filters simply can't capture these tiny contaminants, and that's by design. Pleated media filters are engineered to handle a large volume of oil at high pressure. Because you need a high flow of oil, you can't have a high degree of restriction. That's why the actual depth of the media is so thin. Stretched out, these filters have a large surface area. That's what allows so much oil to pass through. But only the large-size contaminants are captured. Clearance-size particles are washed through, and eventually they wear away the machinery from the inside out. Okay, I understand the problem, I said. Now what's the solution? We have to keep the oil clean continuously, Tom told me. And there's only one way to do that, with bypass oil purification from Triple R. Last year, Tom had installed Triple R's bypass oil purification system on one of our machines. The results were beyond his expectations. Oil that was 100 times cleaner than any other machine in the plant. 3 months ago, he put a proposal on the purchasing manager's desk requesting more units. Unfortunately, with the confusion of other pressing matters, the report was overlooked. Bypass oil purification could have prevented today's disaster. Remember, 90% of failures in hydraulic systems are directly related to contaminated oil. Now I was all ears. How does bypass oil purification work, I asked. First, Tom gave me an overview. Through a T-tap, some oil is diverted from the high-pressure side of the hydraulic system, usually directly after the pump, to the housing of Triple R's bypass oil purification canister. The oil enters the canister on the inlet side of the housing, where a pressure-compensating flow control valve reduces the high-pressure flow of oil to low pressure. At this point, a small amount of oil travels up the center core and down through the element where contaminants are captured, solids as well as moisture. Triple R's high-density oil purification element captures clearance-size particles to less than 1 micron. That's the size of a bacteria cell. The purified oil then returns to the reservoir tank. Triple R produces oil that's cleaner than the specs for the space shuttle. Now I wanted to know what made the Triple R element so special. Tom explained. The element uses a unique 3-stage tapered pore media design that acts like a funnel. Stage 1 provides surface filtration. Its larger pores are designed to capture contaminants in the 10 to 30 micron size range. These are particles we can actually see with decent magnification, so there's an added bonus. We can use this stage as an analytical tool. For example, if there's a lot of steel fragments caught in the top of the filter, it's reasonable to assume there might be metal wear in the system. Rubber debris may indicate seal problems. If this stage had a finer filtration, it would quickly block up with contaminants. Instead, smaller particles can pass through from the top of the tapered pore to the second and third stages as the pores grow progressively more dense. Stage 2, the upper section, captures smaller contaminants as the pores become smaller. And Stage 3, the pressurized lower section, captures submicron contaminants in its densely compressed fibers. I was concerned about how often we'd have to change elements and how long we'd be shut down during the process. Triple R has that covered, Tom assured me, as he broke the vacuum seal on a new replacement filter. Earlier, Tom had turned off a needle valve at the T-tap to isolate the unit from the rest of the hydraulic system. He explained that when the needle valve is turned off, there's never any downtime while changing or inspecting the element. After the initial cleanup period, the element will only need to be replaced 2 or 3 times a year. Triple R has built in a quick and clean method for removal. The whole procedure takes only a couple of minutes. Well, everything sounded great. But as a CEO, it was important for me to understand in precise terms how much cleaner Triple R's system really was compared to other filtration systems. Tom illustrated his point with a graph. The vertical axis represents the degree of oil contamination, and the horizontal axis the passage of time over a period of months. This line shows how contamination increases when the standard pressure line filters are used on their own. This line indicates what happens when an oil filter cart is connected and disconnected. Contamination always returns. And finally, this line displays the dramatic reduction of contaminants when the Triple R bypass oil purification system is installed. The system not only cleans the oil, but keeps it clean, continuously. That's sold me. Continuous oil purification from Triple R, mounted on every machine in the plant, was obviously the way to go. The day the line stopped cost the company a lot of money and aggravation, but something good came out of it. For over a year now, every hydraulic system in the plant has been running smoothly with Triple R's oil purification units. We've had no system failures, no downtime. Our customers are happy, we're happy. Everything's running like a well-oiled machine. And here's a tip. If you haven't installed the bypass oil purification system from Triple R yet, do it now. Don't wait until you have a costly machine breakdown. I'll say it again. Do it now. I speak from experience.